computer vision hands-on. So in today we are going to write a program in Python that will use OpenCV, and the program or concept of today is we are going to apply basic smoothing or blurring of the images. Okay. So this is very important, and sometimes like smoothing and blurring, the term is using interchangeably. Okay. So this is also in context of image processing. Okay. So both terms describe the process of reducing noises and the sharp transitions in an image. Okay. So by averaging the pixel value in neighbors around each pixel. Okay. So this is how the blurring works. So blurring or smoothing works. So basically we will decide some kernel size, and based on that kernel size this will reduce noises. Okay. And so how we do that, we are going to let's write in the code. Okay. And for this one we are going to use Gaussian blur. Okay. So there is many type of blur here, and all these have different use cases and on different conditions, but in this case we are going to use Gaussian blur. So that is very efficient and and most popular, commonly people are using. Okay. So let me first we first import the CV2 library. Okay. So import CV2. Okay. And then we are going to load the images, right? So image CV2 dot im read. Okay. And then pass the path image dot jpg. Any images you can refer. In my case I am going to use this one. Okay. So this image I am going to use. Okay. So this one, let's close this. Fine. After loading, our next step is we are going to apply the Gaussian blur. Okay. So blur image. Okay. And then CV2 dot Gaussian, we are going to use Gaussian blur. Okay. And then here we are going to pass image. Okay. And then we have to decide kernel size. Okay. So based on the kernel size, okay, so it will reduce the noises. Okay. So if your kernel size is smaller, like 3 by 3, 5 by 5, okay, so this will do light blurring. If you are making our kernel size more and more, okay, it will reduce our more noises. Sometime it will remove the important informations of the important details of or information from the images as well. Okay. So 0 indicate that now we are going to pass here 0. So it will set the standard deviations in x or y direction. Okay. Automatically the kernel size will also detect or store the automatically calculate the standard deviations, but by default we are going to assign 0. Also we can assign some custom value. Okay. So that is, there is no any concern. Okay. Finally we are going to show the images cv2 dot im show. Okay. And then call the image object blur image. Okay. Now we are going to define closing one. Okay. Closing the file resources. Okay. 0 cv2 dot destroy all window. Okay. So all the open window we are going to close. Fine. So this was things. Let's run this program. Okay. So this one is our blur images. Okay. So let me, okay, I think let's minimize this one. Okay. I'm going to minimize, then I'm going to show the images. So okay, so this one is our original image and this one is our blur images. So okay, so it's like this. So you can see this one is original. So see, this is I think little bit more cleaner, right? So but this was not, you can see a little bit blurry. Okay. So sometimes it's remove the important informations of the images itself, but there is many use cases where we use blurring effect. Okay. So that is important, like if you we have to check on different kernel. Okay. So, and where these type of things are going to use, okay. So, like in facial recognition system, smoothing or blurring can help to reduce the impact of variation in lighting condition, right. So, due to some lighting condition, we are going to remove the importance detail of the images, okay. And also minor imperfection of the faces leading to improved accuracy in detections. Medical scanning, smoothing or blurring technique are used in medical image applications such as MRI or CT scan to reduce the noises and enhance the clarity of anatomical or anatomical structure, okay, anatomical structure, making it easier to medical professionals to interpret the images, okay. So, these are different use cases. I am not going to detail discuss that one. So, this was the explaining how we can implement the core feature of and how to implement the blurring, okay. So, if you need blurring, so you can use OpenCV library on this. There is some simple function called Gaussian blur and it will reduce, okay. So, there is some other function like common technique for smoothing or blurring in just like included Gaussian blur, there is median blur, okay. So, some common technique for smoothing or blurring include Gaussian blur, okay, median blur and bilateral filter, okay. So, there is 2 or 3 algorithms, okay, but in this case this one is very useful, okay, very common, widely used in image smoothing, okay. So, it convolves the images with the Gaussian kernel, okay. So, which essentially averages the pixel value in the vicinity of each pixel, okay. So, a smaller kernel size in a lighter blurring, while larger kernel size result in a stronger blurring, okay. So, if let me change this kernel size, okay, 15 by 15, let me run this one, okay. So, you can see our images is little more blurry, okay, it like that. Now, let us remove, not remove, I am going to close this one, I am going to write some others, okay. So, let us suppose 25 by 25, okay. So, do this one. So, you have to try based on the images which you want to get, okay. So, this was thing, okay. So, similarly, if you want to apply, suppose I am going to do here 75, okay. So, I think it will whenever in some in image processing or in maybe whenever recording some video, and if you want to blur some images, if you are not going to use some external software. So, if there is coder or if are software developers, you can do with this help, okay. So, you can easily create basic application for blurring the images, okay. Okay, so, you can see lots of information are hidden, okay. So, is this helpful? So, then you can use, but if you are going to use a smaller kernel, okay. So, now our images will be more smoother, okay. It means it we are going to remove the noises, but sometimes image is also considered as a noise if you are increasing our kernel size, right. So, let us run 3 by 3. So, I think you will see more cleaner images, right. So, you can see it will be little bit more cleaner, fine. So, it means just reducing the noises. And what is noises, okay. So, what is reducing noises in images, okay. So, reducing noises in images like diminishing or eliminating the unwanted artifact or irregularity that may distort or degrade the quality of images, okay. So, this will remove that the thing, okay. So, noise in images are caused by various factors like including sensor limitations, environment conditions or transmissions error, okay. There might be some low lighting conditions or maybe some high ISO if you are DSLR, how to click the images. So, in or DSLR if you are using, so ISR setting, ISO setting, not ISR, ISO setting. So, we can these are all happening, these are situations where noises are created, and based on that we will remove that noises, okay. So, this was the things, okay. So, that is all everyone for this video. I think let us meet in another one with some others useful examples. So, if this type of video is somehow adding value to your knowledge, so you can also comment down below. I will create more and more such video, okay. So, thank you so much for watching. Let us meet in another one.